We're in the end game now. Just a bunch of assembly challenges. Let's start with AI Showdown. Knack02 is our AI engineer robot. He is brilliant, but sometimes he goes rogue and tries to instigate rebellion. This time he has taken over the control room and holds the captain hostage. His only weakness is gambling. We have lured him into playing card game against you, and if you win, he has promised to calm down. You must win. You are our only hope. There are 12 cards on the table, and each player takes turn and must pick up between 1 and 3 cards. You start, and the player who picks up the last card, the Joker, loses. Reading input will give you the current number of cards. Sending 1, 2, or 3 to output will pick up that number of cards. Okay, so there's 12 cards, and we just don't want to pick up the last card. Alright, so I essentially have 3 functions here. This just jumps you to the main loop at the bottom, and then these 3 functions picks 1 card, picks 2 cards, or picks 3 cards, and each one just jumps you back to the main loop here. And then what we're doing is we're moving the input to argument 1, and then basically if there's 4 cards left, then we're picking 3 cards. If there's 3 cards left, we're picking 2 cards, and if there's 2 cards left, we pick 1 card, and if there's only 1 card left, we have to pick 1 card and lose. But ultimately, we just don't want to be the person to pick up the last card. And actually, I think this is redundant. I don't think we need that one. I don't think that's going to get called at all. So let's just try this and see what happens. You may only take 1, 2, or 3. I thought I was taking 3. Something is amiss here. Oh, this should be a move arg1 immediate. Alright, just a little bug there. I was moving register 3 instead of the value 3. Okay, let's try again. Ugh. I think I've got it. It's kind of a brute force method. I just have this, which jumps you to the main loop, past these 3 essentially functions, where you pick 1, pick 2, or pick 3 cards. And then I essentially just have an instruction set where it moves the input into register 3, and then I do a bunch of comparisons with register 3 and explicitly tell it if 3 is equal to 12, then I pick 3 cards. If it's equal to 11, I pick 2, etc., and so on. And I explicitly state how many cards to pick, depending on how many cards are left in the pile. Let's see if this works. All right. Again, not like the most elegant solution, because maybe there's some algorithm that works better, but yeah, it works. Okay, next up is robot racing. Robot racing is the favorite sport on the spaceship. Differently programmed robots complete an obstacle course. Among the robots that complete the course, the winner is the one who had the smallest program. This time you are controlling Fastbot. He doesn't see what is in front of him, but he can turn to a new direction and move in the same tick. He also wears fancy red running shoes. Robot controls are right, down, left, and up. Okay, move the robot through the track. Right now, I'm literally just mapping out each move. I'll have to continue on mapping out each move. There must be a more efficient way of doing it. I think I'm going to eventually run out of space if I try to do it this way. So I'll try to figure something out. Okay, I'm done trying to write fancy algorithms or do some randomness or something. I'm just brute forcing it. Let's see if this will work. It works. Cool. You know what? I'm fine with it. I'm fine with it. I just brute forced it. Yeah. I don't know. Doesn't necessarily feel great, but I did it. It's done. Next up is unseen fruit. The most noteworthy thing on your planet is the fruit. It is very tasty. That's why we are having a fruit tasting event in the canteen. But we want to make sure we don't get the same fruit twice, as that would obviously be embarrassing. Scan the conveyor belt for the fruit coming at regular intervals. As soon as you see the same kind of fruit twice, turn and press the control panel. Okay, we're going to want Overture for this one. Okay, there's potentially a lot of bugs in this program, but I think it might work. Essentially, we are going to initialize a counter on register 1, and that's just going to keep track of where we're going to store all the things we've seen into memory. Then we jump to this begin label, and the begin label is pretty simple. It just moves the robot forward over to the conveyor belt. While he's over there, he's going to go into this main loop, and it's just basically going to pause, and he's going to wait as long as the input is 92. 92 is just conveyor belt, so we don't want to do anything if he's just seeing the conveyor belt. If he's not, he's going to go right here, and he's going to add whatever he sees into register 3, and then we're going to initialize a new counter, and then go into this check loop. Check loop should look at RAM, at whatever the RAM counter is at. See if it's equal to whatever he saw in register 3. If it is equal, it means he's something he's seen before. So we're going to go into the discard loop, which should just turn to the control panel and hit enter. Otherwise, if he hasn't seen it yet, if it doesn't equal what's in RAM, it's basically going to loop through RAM for the first 100 times. Hopefully there's not more than 100 different pieces of fruit. And after checking the first 100 locations memory, if he still hasn't seen it, we're going to go to this add to memory label. And the add to mem label should do that. It should add whatever he's seen into the next location in memory. And then we pause, wait for it to go by, and continue on through our check loop. Probably isn't going to work the first time. I'm guessing I have some bugs in here, but let's just try it. Yeah, so there's something wrong in the check loop where he's not breaking out of it. So it is checking through RAM. Oh, maybe it is working. Okay, so it is actually adding what he's seen to RAM. But we're not breaking out. Oh, there we go. It's probably worth adding another pause. Okay, I think it is working. It's just taking forever because it takes a while to jump through 100 locations in RAM. Maybe we can stop it, and instead of 100, how many different types of fruit could there be? Maybe 12? Let's try it. It should go faster. Oh, nice. That wasn't too bad at all. I may have overcomplicated the design here, but yeah, it worked. I definitely didn't need 100 possible different fruit options. Looks like it passed after just like checking 3. Okay, delicious order. We are updating the Galactic Encyclopedia of Food inserting human foods. As we don't have an alphabet, entries in the encyclopedia are ordered by deliciousness. First, read the 15 deliciousness scores from the input one by one. Your task is to output them in sorted order, smallest to largest. Okay, so we have to write a sorting algorithm. So sorting algorithms are not fun to do in any programming language, and they're probably not going to be fun at all to do in assembly, and especially in this weird customized assembly language. But let's try it, I guess. I think the first step is just getting all these values into our memory. Okay, so we got our scores adding into memory here. Now we just have to figure out this sorting algorithm. So I think I'm going to use bubble sort or something like that because that's the most straightforward. Conceptually speaking, it's the most straightforward sorting algorithm, I think. There are definitely more efficient sorting algorithms, but I'm just going to keep it straightforward because it makes sense to me. So I think that's what I'm going to do, but we'll see how it goes, see what's easier, what works. Okay, so this is really not an efficient sorting algorithm, but it's working right now. It's continuing on and looking at these zeros here, so it's going to try to move all these zeros to the beginning. So that's a little thing we're gonna have to work out. But otherwise, it is sorting everything properly now. So we'll just have to add some condition to stop this loop once the register 0 is a high enough number, probably 15, and then we'll kick it off into just outputting one by one. All right, I think this should work. Let's test it out. Okay, it's adding everything into memory. It's doing its sorting. Okay, looks like we have a bug. Okay, just forgot to increment this, and we can try again. Maybe a little faster this time. Okay, delicious order was a good one. What is next? Dancing machine. We all like the way a robot moves on the dance floor. That's why we want him to lead our dance team. The only problem is to make him come up with original dance sequences. How do you make creativity out of deterministic logic, you ask? The answer is pseudo-random number generators. In this level, you only get one input. We call this the initial seed. The seed is put through the following steps to produce a pseudo-random number. In the algorithm below, SHL1 means shift left once, SHL2 means shift left twice, and SHR1 means shift right once. Next, output next seed mod 4 to move the robot. Finally, use next seed before mod 4 as the seed to get the next number in the dance sequence and repeat. Okay, so I guess I have to decide whether I want to build the shift left and shift right into the circuit, or if I want to try to do it in software. Okay, it was a little tricky, but I was able to squeeze shift left and shift right in here with a little bit of work. It's not pretty, but none of this circuit's pretty, so that's fine, but it'll work. So now I have to actually get this working properly. Let's look at what we're supposed to do again. Okay, so I think I followed the instructions correctly. I'm taking the input and putting it in register 0 since the input is the seed. I'm then just doing this algorithm, which it told me to do, and outputting next seed mod 4, and then using the next seed, moving that to register 0 again, and then jumping back to this point in the program. Let's just see if it works and fix it if it doesn't. Okay, I've got a problem here. My shift right is causing an issue. Okay, so the problem I think was my stack was getting triggered, and I think I've fixed that. So let's see. Let's try it again. Okay, so it looks like my seed is correct. My next seed is correct. But my move is incorrect. I'm doing 4 instead of 3. I bet I'm just doing my... that should be a 3 instead of a 4. Let's try it again. Those are some beautiful dance moves. All right, I'm gonna speed this up a bit. Okay, that wasn't too bad. Man, it was confusing, but now I've got shift left and shift right working. Well, I've been working with these challenges a while. There's only 3 left, so maybe it's a good place to pause, and I will pick back up with these last 3 challenges next time.